Okay guys, we're going to do our notes for dividing polynomials. So you'll need your little notebook open. You'll find it either in your Google Classroom assignments or your shared documents. It'll probably be there. And then you need Unit 2A from your workbook. I don't know what page number it is, but it's examples 2A.3.2. So examples 2A.3.2. So go find those. All right, in our table of contents, you guys can go ahead and fill out slides 16 through 18, dividing polynomials. Go ahead and pause here. And then, like I said, you need to define Unit 2A, your workbook. It's 2A.3.2. So find the examples that are dividing polynomials. We're going to start with just one example because it's what we did in class today, and then we'll go do our other stuff. So it says use synthetic substitution to evaluate p of x equals x squared minus 32 for x equals -7. So the first thing that maybe that you should notice is that in our polynomial, we're actually missing the x term. So we have to fill in that 0 term for x. I'm going to set up my synthetic substitution little bars over here. So remember that whatever number you're plugging in is what goes in this first box. And then whatever your coefficients are, so there's a number 1, 0, and -32. That's what gets listed right here. So 1, 0, -32. I like to put like lines down so I can kind of separate them. And then our answer is going to be whatever is here in that box. Okay, so we did this today in class. The first thing you do is move down your first number, that's 1, and then you multiply by whatever's in this box outside. So -7 times 1 is -7. You add coming down, that's -7. Multiply by what's in the box, so -7 times -7 turns +49. Add coming down, -32 plus 49, you could also say 49 minus 32, which is 17. So our substitution, we got p of -7 because the function is called p, that's its name, it's like Paul, and then when you plug it in, you get 17. So that's our answer. All right, now we're going to do the other 4 examples after we do the parts of our notes, okay? All right, so remember you guys can just type these in. You don't have to, you're not handwriting, you're just typing them in, so just highlight the line. So dividing polynomials. So when dividing polynomials, there's 2 ways. The first way we're going to do is something called long division. So just like when you do long division in elementary school, we're pretty much going to follow the same exact kind of steps. The way that it is going to be set up, it's going to be the first polynomial is your dividend, and that's what gets written underneath. There's like a text box in your guys' presentation, so you're just going to type it in right there. So the polynomial that comes first is our dividend, that goes under our little long division bar, and then whatever comes second is our divisor, and that's what we put on the outside of our division symbol. On the top is where you will find your answer. Okay, so the first polynomial goes under the bars, the second polynomial, the divisor, goes outside your bars. When a polynomial is missing an exponent, so just like we did with our synthetic substitution problems, if you're missing an exponent in descending order, you must add a 0 term. So just like we have here, it says 3x to the 4th, 7x squared, -5x plus 4. So notice how there's no power of 3. There's no x cubed term. So what happens is it becomes 3x to the 4th plus 0x cubed plus 7x squared minus 5x plus 4. So it had a power of 4, power of 2, power of 1, a constant. Even if it's missing the constant, you still have to put a 0 term. Here's our steps for dividing polynomials using long division. I'm not going to like read through those, but when you guys are working on your homework, if you get stuck on a step, you can always look here and try to like look through the steps and figure it out. Okay, so here's our long division problem. So I'm going to warn you, long division is pretty long. That's why it's called long division. It's similar, like I said, to long division that you do in elementary school. Okay, so the first thing we're going to do is go ahead and draw our long division bars. So we set it up with our long division bars. And then remember that the first polynomial, make sure we don't have any 0 terms, x squared minus 5x minus 20. It has all of our exponents, power of 2, power of 1, and a constant. That one gets written underneath. Then we have our divisor. That's the second polynomial. It's x minus 4. Okay, so the steps are written in your notes, okay, on that slide, but the first step is what you're going to try to do is you're going to try to see what you would multiply to get this first part of your divisor equal to this first term of the dividend. So what would you multiply x by to get x squared? Well, you would multiply by x. So over on the side here, I'm going to kind of show my work. I'm going to multiply x times x minus 4. Okay, and when I do that, I'm going to write it right underneath this dividend. Oops, I didn't mean to erase that whole thing. Sorry. X squared minus. Okay, so when I multiplied it, x times x minus 4, I'm going to write that right underneath. I get x squared minus 4x. So just like with regular division, once you write something underneath, then you subtract, okay? When you subtract, remember you have to subtract both pieces, so that actually turns this term positive, because when you distribute, this positive turns negative, and then the 4x was negative, so it turns positive. And then what happens is this piece cancels out, and then you subtract negative 5x plus 4x is negative x, okay? Then what you would do would be to move down. Once you've run out of, your terms, you move down a number. So we're going to move down negative 20. And then we're going to think to ourselves, okay, what would I multiply x by right here to get this negative x? So what would I multiply x by to get negative x? Well, I would multiply that by negative 1. So I'm going to multiply show my work over here. I'm going to multiply x minus 4 by negative 1. And when I do that, erase more easily here. When I do that, I end up with negative x plus 4. X times negative 1 is negative x. Negative 4 times negative 1 is positive 4. And then again, I'm going to write that up here. I multiply by negative 1. I forgot to write that up here on the top. And then I go ahead and subtract. So when I subtract, I have to change the sign. So this becomes positive and this one becomes negative. These cancel out and I get negative 24. So here you would keep working if you had more terms to bring down, but I don't have anything more to bring down. So what this little piece is right here, since there's nothing else to bring down, this is my remainder. So if you recall, we wrote on the last page that my answer is what's up here on the top, this x minus 1, plus the remainder. So my answer is x minus 1 plus my remainder is negative 24 over whatever I was dividing by. Okay, so it's called long division because it's pretty long. That's why we have a second way that we are going to do things, which is called synthetic division, which is like the synthetic substitution we did in class. But the thing is, you can't always use synthetic substitution. It only works if you're dividing by a binomial in the term of like x plus or minus a number. Long division always works. So the steps are written down, but what you do is you try to match your first term to match whatever comes first in your little binomial. When you know what that is, you put that on top, you multiply by it, and then you bring down, you subtract and then bring down the next term. And then you try to match that first term with the first term of your divisor. I know it sounds kind of confusing, but that's why we're going to have a second method. We're going to use synthetic division. So the second way to divide polynomials is by synthetic division. But it only works if the divisor is a binomial in the form of x plus or minus a, just x plus or minus a number. Okay, so if it is in the form of x plus or minus a, so the example we have right here is 10x to the 4th minus 10x squared minus 2x plus 4. Notice there's a 0 term, there's no x cubed, so my coefficients are 1, 0, negative 10, negative 2, and my constant is 4. Notice how the synthetic division piece over here is a. How you get that a is you actually have to set your divisor, x plus 3, you set it equal to 0 and solve. So for this example, you would subtract 3 on both sides and you would get x is equal to 3. So that's what you're plugging in, that's what you're trying to find. You're going to do all your synthetic substitution like we did today in class, and then what you'll find is that what used to be our answer is now the remainder. And the number next to that is our constant, and the number next to that is our coefficient on x, and the number next to that is our coefficient on x squared and x cubed, and it just keeps going however many numbers are there. So we're going to do a few examples of this so you guys can see how it works, but the way that it works, remember, is that what we used to have as our answer is now the remainder. And the way that we get this number that we put outside for a is we take our divisor and set it equal to 0. So let's go do some examples. Our example 2 is actually the same exact problem as example number 1, except for number 1 told us to use long division and number 2 wants us to use synthetic division. Okay, so the way that it works is we're going to go ahead and first decide if we need any zero terms. I have x squared, x, and a constant, so I'm not missing anything. I don't need any zero terms. So I'm going to make my synthetic substitution bars. I can list out my coefficients. So my coefficients were 1, -5, -20. And then I have to find what number I'm going to plug in to my little synthetic bars. So see how it says x minus 4? Well, what you do is you set that equal to 0 and then solve. So you would add 4 to both sides and you get x equals 4. So once you find what x equals, that's what you're plugging into the bars, or to the box. Okay, so synthetic division. The first step is to move down your first term, that's 1, and you're always going to multiply by what's in the box. So 4 times 1 is 4, add coming down, multiply by what's in the box, add coming down. So again, whatever is in this box is your remainder. Whatever is next to it is your constant. This is your coefficient on x, and then if there was more, it would be in front of x squared, x cubed, whatever. So your coefficient in front of x is 1. We don't have to write that. My constant is -1, so it doesn't get a variable. And then you add your remainder over whatever you were dividing by. I was dividing by x plus 4. Technically, you would probably write this as a minus sign instead of plus a negative. You would just say x minus 1 minus 24 over x minus 4. So again, the way, after you do all your synthetic substitution, like we did yesterday in class, this box is your remainder, the number next to it's your constant, and the number next to it's your coefficient on x, and then x squared, and however many there are. Let's try this again so you guys can see how it goes. So example 3, it says find the quotient of 3x squared plus 3x cubed plus 16x squared plus 18x plus 8 divided by x plus 4 using synthetic division. All right, so I'm going to check for zero terms. I see a power of 3, power of 2, power of 1, constant, so I don't need any zero terms. So I'm going to set up my little bars. So my coefficients are 3, 16, 18, 8. And then the number that I use to plug in, well, since it says x plus 4, I set that equal to 0. And I'm going to plug in minus 4. So it's the opposite sign. If this says x plus 4, I'm going to use minus 4. The last example said x minus 4, I used plus 4. So it's the opposite sign. Okay, so let's go and do our synthetic division. So I'm going to move down my first number, that's 3. Multiply by whatever's in the box outside. So 3 times -4 is -12. I add coming down, 16 plus -12 is 4. Multiply by -4, I get -16. Add coming down, I get 2. Multiply by -4 on the outside, I get -8. Add coming down, I get 0. What it means when you get 0 is actually a good thing. That means there's no remainder and it divides in evenly. So we like that. We like when our remainder is 0. So that's our remainder. Next to it is our constant. Next to that's our coefficient on x. Next to that would be x squared. And if there was more numbers, it would just continue, x cubed, whatever. So my answer is I use these numbers on the bottom and the coefficient and the variable. So it would be 3x squared plus 4x plus 2. Since there's no remainder, I don't have to write it. So it's my constant. The 4 goes on x. The 3 goes on x squared to get my answer. All right, one last example. It's number 5. It says, if the remainder of x squared plus kx plus 34 divided by x minus 5 is equal to negative 21, what is the value of k? All right, so I'm going to set this up like my regular division, okay? I have my coefficient, or my divisor. Dividend says x squared, x, and a constant, so I don't need any zero terms. My coefficients would be 1. I'm trying to find k. That's what I'm trying to find. And then 34. It tells me that I'm dividing by x minus 5. So remember, what goes in the box is if you set x minus 5 equal to 0 and then solve. So in the box is actually going to be plus 5. And it says that my remainder, if the remainder is negative 21, well, the remainder normally goes in this box down here. So I'm going to put my remainder in that box. What I'm going to do is I'm going to use my synthetic substitution, synthetic division. I'm going to try to find what k is. That's the goal. So I'm going to move down my first term. That's 1. 5 times 1 is 5. Normally we add coming down. Well, I can't actually add them, so I'm just going to put them together. K plus 5 with a plus sign in between. Remember, you're multiplying by whatever number's out here. So if you multiply k plus 5 times 5, you have to distribute it onto both. I get 5k plus 25. All right, we're almost to our answer. Then we know that what we're supposed to do is add these two things, and it should be equal to our remainder. So if I add 34 plus 5k plus 25, it should be equal to negative 21. All right, well, let's go ahead and get this all solved for then. I'm going to subtract my 34 on both sides. I get 5k plus 25 equals negative, what is that, 55. I'm going to subtract another 25 to the other side. I get 5k equals negative 50, 60, 70, 80. And then the last step is to divide by 5. A negative divided by a positive is going to be negative, and 80 divided by 5 is 16. So my k is negative 16. And that's all that one wanted us to find. So synthetic division is like what we did in class today of synthetic substitution, but once you find all the numbers that are at the very bottom, the remainder box, or the what used to be our answer now our remainder box, and then the numbers next to it are coefficients that go in front of our terms. So we already filled out our notes. Those examples that we just did go right here on slide 18. So you just cancel all this stuff out and put your examples there. And then what do you do now? Well, if you have any questions, you could put them on that sticky note on slide 16, so you remember to ask them when you come to class tomorrow. Write your summary also on the slide, the sticky note that's on slide 16, and then upload a picture of your examples onto slide 18. And then we're going to do dividing polynomials tomorrow in class. Okay, thanks.